Welcome back to Dr. Finance. This is a paper by Leonid Kantorovich, who won the Nobel Prize in Economics in 1975. His paper, published in Management Science, 1939, Mathematical Methods of Organizing and Planning Production. So let's go. Introduction. The immense tasks laid down in the plan for the third five-year plan period require that we achieve the highest possible production on the basis of the optimum utilization of the existing reserves in industry, materials, labor, and equipment. There are two ways of increasing the efficiency of the work of a shop, an enterprise, or a whole branch of industry. One way is by various improvements in technology, that is, new attachment for individual machines, changes in technological processes, and the discovery of new, better kind of raw materials. The other way, thus far much less used, is improvement in the organization of planning and production. Here are included, for instance, such questions as the distribution of work among individual machines of the enterprise or among mechanisms, the correct distribution of orders among enterprises, the correct distribution of different kinds of raw materials, fuel, and other factors. Both are clearly mentioned in the resolution of the 18th Party Congress. There it is stated that the most important thing for the fulfillment of the goal of the program for the growth of production in the third five-year plan period is the widespread development of work to propagate the most up-to-date technology and scientific organization of production. Thus, the two lines of approach indicated above are specified, as well as the introduction of the most up-to-date technology. The role of scientific organization is emphasized. In connection with the solution of a problem presented to the Institute of Mathematics and Mechanics of the Leningrad State University by the Laboratory of the Plywood Trust, I discovered that a whole range of problems of the most diverse character relating to the scientific organization of the production, questions of the optimum distribution of the work of machines and mechanisms, the minimization of scrap, the best utilization of raw materials and local materials, fuel, transportation, and so on, lead to the formulation of a single group of mathematical problems, extremal problems. These problems are not directly comparable to problems considered in mathematical analysis. It is more correct to say that they are formally similar and even turn out to be formally very simple, but the process of solving them with which one is faced, i.e., by mathematical analysis, is practically completely unusable, since it requires the solution of tens of thousands or even millions of systems of equations for completion. I have succeeded in finding a comparatively simple general method of solving this group of problems, which is applicable to all the problems I have mentioned, and is sufficiently simple and effective for their solution to be made completely achievable under practical conditions. I want to emphasize again that the great part of the problems of which I shall speak relating to the organization and planning of production are connected specifically with the Soviet system of economy, and in the majority of cases do not arise in the economy of a capitalist society. There, the choice of output is determined not by the plan, but by the interests and profits of individual capitalists. The owner of the enterprise chooses for production those goods which at a given moment have the highest price, can most easily be sold, and therefore give the largest profit. The raw material used is not that of which there are huge supplies in the country, but that which the entrepreneur can buy most cheaply. The question of the maximum utilization of equipment is not raised. In any case, the majority of enterprises work at half capacity. In the USSR, the situation is different. Everything is subordinated not to the interests and advantages of the individual enterprise, but to the task of fulfilling the state plan. The basic task of an enterprise is the fulfillment and the over-fulfillment of its plan, which is a part of the general state plan. Moreover, this not only means fulfillment of the plan in aggregate terms, i.e., total value of output, total tonnage, and so on, but the certain fulfillment of the plan for all kinds of output, that is, the fulfillment of the assortment plan. The fulfillment of the plan for each kind of output, the completeness of individual items of output, and so on. This feature, the necessity of fulfilling both the overall plan and all its component parts, is essential for us, since in the setting of the task connected with securing maximum output, we must consider the composition and completeness as extremely important supplementary conditions. Also extremely important is the utilization of materials not chosen in some a priori way, but those which are really available, in particular local materials, and the utilization of materials in accordance with the amount of them produced in the given region. It should be noted that our methods make it possible to solve the problems connected precisely with these real conditions and situations. Now, let us pass to an examination of various practical problems of organization and planning of production, and let us ascertain the mathematical problems to which they lead. Going all the way down to page 23. Conclusion. Conclusion. A. The general significance of the work. I see the basic significance of this work in the fact that it has developed a method of solving that kind of problem in which it is necessary to select the most advantageous from amongst a huge number of different cases and variants. Moreover, the given method makes the solution of the problem fully possible, often even in extremely complicated cases, where the selection of the most advantageous variant must be made from among millions or even billions of conceivable possibilities. The method is also applicable where it is necessary to take various additional considerations into account. It is generally known that this kind of question is constantly met in technical economic problems, particularly in those dealing with the organization and planning of production. Many of these problems lead directly to problems A, B, and C examined above, and therefore can be solved by our methods. Many other practical problems lead to mathematical problems, which are different from these but can still be solved by the same methods. Up to the present time, although all these technical economic problems have been solved more or less haphazardly by eye or by feel, and of course, the solution obtained is only in rare cases the best. Moreover, the problem of finding the optimum has often never even been posed, and when it was posed, it has not been possible in the majority of cases to solve it. The possibility now exists in a number of cases to obtain not an arbitrary solution, but to find the optimal solution by a definite, scientifically based method. B. The directions of further research. In its present form, this work is far from finished, of course, and in a large degree does not meet the demands which are placed upon it. The given work is only a preliminary outline of a future thorough study on this theme, in which it will be possible to clarify rather fully that important problem which up till now has for the most part only been posed. In order to achieve this, further extensive researches still have to be carried out by the combined efforts of mathematicians and production workers. Much still remains to be done on the mathematical aspect itself, although an important step has been made. An extremely universal and rather effective method of solving a wide class of problems has been given. In the future, it remains to determine the sphere of application of the method to indicate further problems solvable by it, to work out the details of the technique of applying the method, to emphasize the distinctive features of this technique in different practical conditions, to work out simpler methods which will make it possible to find, if not the optimum solution, one extremely close to it and practically identical with it, to improve the exposition of the method, and so on. Still, more effort will be required to foster the actual utilization of this work by technicians and specialists in the different branches of the national economy. Above all, it is necessary to define those problems in different fields of the national economy where the applicability of our methods is most feasible and realistic. We have made some attempt to outline and indicate these questions in the present work, but of course, it is difficult to expect them to be fully successful and not to evoke criticism on the part of specialists. It is possible that several of these problems will be shown to unrealistic or unimportant. In others, there will be essential correlations and additions. Finally, there is no doubt that a number of other problems which have completely escaped our attention will be raised. Nevertheless, we considered it necessary to make such an attempt on the assumption that our methods would be more understandable and meaningful to an engineer if they were connected with concrete practical problems, and we pointed out a large number of such questions of divergent character to permit him to imagine better and to outline for himself the range of problems where our methods are applicable. He can also evolve and pose various similar problems in his own field. That is, he can facilitate the creative application of these methods. After defining the fields in which the mathematical methods can be applied, the question will arise of the specifics of applying these methods to given questions. This involves a precise clarification of the circumstances under which these methods can give an appreciable effect and their application demonstrated. The working out of special technical data which are necessary for the application of these methods, the translation of these data into a form suitable for utilization of tables, the working out of the details of the method specifically for the problems met with in a given field, indication of a rule for the selection of a first approximation, for example, and so on. C. Answer to several of the principal objections. As we have already indicated, we consider it probable that some of the examples analyzed here and possibly a whole field of questions will encounter objections on the part of specialists. We realize that in individual cases, it is possible for these objections to be so well-founded as to force our withdrawal from a certain field of application. However, along with these special individual objections, we have been required to counter in part of the extremely favorable opinion of the majority occasional objections of a general character, which essentially lead to the denial in principle of the possibility of using mathematical methods in technical economic questions in the field of organization and planning. At this point, I wish to examine these general objections. The first consists of the following. In examining different practical, concrete problems, the situation is so complex, there are so many circumstances to be considered, that it is impossible to take account of them all mathematically, or if you succeed in doing so, then the questions obtained are still impossible to resolve. We can make two remarks in reference to this. In the first place, as we have already shown, the indicated method is very powerful and flexible. That is, it obtains solutions in extremely complicated circumstances while taking account of a number of additional conditions. Moreover, it permits different variations in using it, so that it is always possible to choose the most suitable method. In the second place, if some practical detail has been left out of account, then after the optimum solution is found, it is possible to correct it with reference to this detail. This is all the more possible since the given method should, along with the finding of the optimum solution, what variant give a solution close to the optimum, so that there is the possibility of departing from the optimum solution only slightly in introducing the correction. It should also be said that the objection noted could be equally justly raised to the use of any theoretical and in particular mathematical methods in technical questions generally. It is well known how technicians value even the crudest theoretical representation of a phenomenon, for even that which considers just one of many factors involved is an extremely powerful guiding force in experiments, in calculations, and in designing. All the more valuable should be a method which allows a whole range of considerations to be taken into account in complicated situations. A second objection is that in using the method, it is necessary to have a whole series of data, alpha sub ik, in problem A, and so on. But such data may not be available, and then we cannot use the method. The answer is that the data which are needed, output norms on different machines and pieces of equipment, the quantity of different materials and their characteristics, and so on, are necessary for many other purposes, such as for norm setting, wage calculations, norms for the expenditure of materials, reports, and so on, and should exist in any normally working enterprise. In short, they are just as necessary for making any kind of plan as for making the best plan by our methods, and therefore the enterprise ought to have these data at its disposal. In several cases, it still turns out that such data are lacking. For example, some material is supposed to arrive at a construction project. It is not known just what kind, but in any case, it must that very day be put to use, or materials are sent which are different from those planned, and so on. Of course, in those few enterprises where such primitive mismanagement reigns, no planning, even the most suitable, is possible. But if the desire to use our methods serves as an added stimulus for the elimination of such negligence, then this is only another argument in favor of this method. The third objection is that the original data in a number of cases are doubtful and known only approximately. For example, the yields of different crops, the expenditure of water on hydromechanical working of earth, and other data in several of the examples introduced above, and therefore a calculation based on these data may be incorrect. Here, it is necessary to say first of all that in individual cases, the optimum variant of a plan found by our method may indeed not be the optimum one because of the inaccuracy of the data. However, we suppose that in the mass application, the choice of the most advantageous variant, even with such doubtful data, will give thanks to the statistical effect, an effective result. Let us clarify this by the following simple example. If we take the larger of 2 eggs, such a solution may be unfortunate. The egg may turn out to be rotten. But if out of a box of 1,000 eggs, we choose the 500 largest, it is completely implausible that this choice would turn out to be wrong. The fourth objection is that the effect of changing from the ordinary chosen variant to the optimum one is comparatively small, in many cases only about 4 to 5%. Here it is necessary in the first place to say that the use of the best method does not demand any additional expenditures in comparison with the usual one, except the absolutely insignificant expenditures on calculations. In the second place, the use of the method can be expected not in a single isolated problem, but in many. It is possible that it can be used even over the greater part of the branches of the national economy, and in that case, not just 1%, but even each 1/10 of a percent is associated with tremendous sums. The fifth objection is that in a number of cases, the use of the method is impossible as a result of various obstacles of an organizational character connected with the accepted procedure for approving plans, estimates, and so on. For example, if this or that material or mechanism is already distributed in a certain way between enterprises, then this distribution cannot be changed during the interval of the given quarter, and so on. This objection, of course, is not essential if it is generally recognized that the use of the most effective plan results in a significant national economic effect, but that its introduction requires certain changes in procedure, then there is no doubt that such changes will be made. Thanks for listening.